BMTPC. I welcome you all in this webinar series. I welcome you all to this webinar series which BMTPC started a few months back, and this is the 7th of the webinar we are conducting today. And we have the privilege of having Professor Subrata Chattopadhyay and Professor Shankha Bhattacharya ji from IIT Kharagpur, who will be delivering the lecture today, and they will be talking on the bamboo technology which has been developed by IIT Kharagpur. In fact, I am waiting for Shri Arvind Kumar. Arvind Kumar ji is also there. Our earlier executive director, Dr. Shailesh Kumar Agarwal, has retired in November. And now we have got our new executive director, Shri Arvind Kumar, who has also joined today in this webinar. I welcome you all for this webinar once again. And I would invite Shri Arvind Kumarji to say a few words and welcome the participants.
Am I audible, Pankaj?
Yeah, Arvindji, you are audible.
Okay, good afternoon to all distinguished speakers, participants, and colleagues. I extend a warm welcome to all of you to webinar series 7 on innovative building materials and technology for thermally comfortable green buildings, organized by the Building Materials and Technology Promotion Council, as an autonomous organization under the aegis of the Ministry of Housing and Urban Affairs and Government of India. See, today's session on low-cost bamboo housing and bamboo reinforced mortar wall system is highly relevant in the context of affordable housing, which our ministry is very, pitching very hard. And it is for the purpose of sustainability and promotion of indigenous renewable building materials. Of course, this webinar, participant can expect to gain practical and policy relevant insight into the technical feasibility, structural and thermal performance, and field applicability of bamboo-based construction system, with a view towards their wider adoption in the housing and building projects. As I assume charge as Executive Director, BMTPC, it is really encouraging to see continued engagement from our academia professionals and implementing agency on such outcome-oriented themes. We are privileged to have with us Professor Subrata Chattopadhyay, Professor Emeritus, IIT Kharagpur, a leading authority on housing and energy efficient settlement, and Dr. Shankha Pratim Bhattacharya, Associate Professor, IIT Kharagpur, again an expert in building science and structural systems. In this context, I would also like to briefly draw attention to relevant BMTPC publications on bamboo and alternative building materials, which complement today's discussion. These applications bring together technical design guidance, material treatment, and durability aspect, construction detailing, and from a pilot and demonstration project which was supported by the BMTPC. They are intended to serve as a practical reference documents for planner, architects, engineers, and implementing agency, those seeking to adopt bamboo-based and other sustainable construction technologies. So with these remarks, I request the moderator to kindly take the proceeding forward. Thank you very much. Pankaj, please go ahead.
I'll take over. Thank you, Arvindji, for your opening remarks. And before starting the presentation, I would like to, it's my privilege to introduce Professor Chattopadhyay and Professor Bhattacharya. To start with the introduction of Professor Subrata Chattopadhyay. Professor Subrata Chattopadhyay, an eminent academician, planner, and researcher with over 35 years of distinguished professional experience spanning teaching, research, consultancy, and academic leadership. Professor Chattopadhyay holds a PhD from IIT Kharagpur along with the advanced qualifications in housing and urban planning from SPA Delhi, Lund University, Sweden, and Newcastle upon time, UK, and a bachelor's degree in architecture from Calcutta University. He is currently a professor emeritus and formerly head of the Department of Architecture and Regional Planning at IIT Kharagpur and has also served as Dean of Alumni Affairs. His expertise lies in housing and community planning, township planning, energy efficient settlements, urban heat island studies, peri-urban dynamics, and urban brownfield redevelopment projects. He has also been closely associated with the Ministry of Housing and Urban Affairs, Government of India, contributing to the flagship initiatives such as Pradhan Mantri Awas Yojana Urban and the Global Housing Technology Challenge India, which was conducted in 2019 by the ministry, and also has led several nationally and internationally significant research and consultancy projects. With this introduction, I welcome Professor Subrata Chattopadhyay, and also I am equally honored to welcome Dr. Shankha Pratim Bhattacharya, a respected academic and architectural engineer with more than 25 years of teaching and research experience. Dr. Bhattacharya is currently an associate professor in the Department of Architecture and Regional Planning at IIT Kharagpur. He holds a bachelor's degree in architectural engineering from NIT Calicut, a master's degree in structural engineering, and a PhD from the Birla Institute of Technology, Misra. His areas of expertise include building science, construction management, thermal comfort, building energy modeling, structural systems, and disaster risk and vulnerable assessment. He has developed NPTEL courses published extensively in reputed international journals and conducted various national level academic and professional training programs. In recognition of his contribution in the field, he was awarded the Eminent Architectural Engineer Award by the Institution of Engineers India. We are delighted to have him share his insights and experience with us today. With this introduction, I would request Professor Subrata Chattopadhyay to start his presentation, and we will be having a presentation of around 1 hour, and after that we can have question and answer sessions, and meanwhile if you want you can put your queries in chat box also. With this, I request Professor Chattopadhyay to take over.
Thank you very much, Pankaj ji, and thank you very much, Executive Director Saab. It is the first time that we have met you. I hope you can all hear me.
Yes, sir. Yes, sir. Very much audible, sir.
Okay, okay, and my camera is also working. Shankha has started sharing the screen. Can you all see the screen? Can we have it in the presentation mode, Shankha?
Right now it is not visible. If it is visible to other participants, they can also confirm.
No. Shankha,
it's visible.
not visible. It's visible?
Yes, sir. Yes, it is visible.
Yes, sir, it is very visible.
Okay, okay.
Is it visible full screen mode?
Are you seeing it in full screen?
Yes, yes.
Yes, it's visible.
Full screen. Okay, excellent. So thank you very much for this, for having us here. And we would be talking about a live project that we have on bamboo housing. And we are delighted to have this project, and we would be giving a brief account of what we did, how it came to us. But for any further clarification details, we are always available to all of you. So very good afternoon. Now you all know that straight coming to the point, we talk about the National Bamboo Mission, right? You must have all heard about the National Bamboo Mission that was launched in the year 2006, and it was restructured in 2018, 2019. Now, what was the objective of this National Bamboo Mission? Now, the major objective of the National Bamboo Mission is to develop an entire bamboo value chain, right? There is a huge potential of bamboo, and the mission says that we would like to develop an entire bamboo value chain. And that would include steps, for instance, cultivation to marketing to income generations for rural peri-urban areas to livelihood generation to green economy. So this was the overarching goal of the National Bamboo Mission. Okay. The impact that is supposed to be, this mission is supposed to bring in is to revitalize bamboo sector as a green economy sector. And the impact is also going to significantly increase the rural as well as peri-urban income. So this is the backdrop. Okay, this is the backdrop. Again, why bamboo? You must be, asking. And I'm sure you people, you are all aware that bamboo is a species of grass, and it is the fastest growing species or among the fastest growing species. So bamboo has got several key features that makes it as an automatic choice and a subject to really research on. So let's see. Number one, bamboo buildings have lesser carbon footprint, and some experiments say that it can be less by more than 20% than conventional brick buildings. Number two, bamboo grows very fast. It grows very fast. Not only that, it also has the property of carbon sequestration. That's one of the most important factors, that it absorbs the carbon that is emitted through greenhouse gas effects. So bamboo, high growth rate and huge capacity of carbon sequestration. If we consider brick and concrete buildings, they are very energy intensive. If we do a life cycle analysis, we will see that brick and mortar, brick and concrete buildings are energy intensive, and also they release a lot of emissions. In that respect, we can say bamboo has got zero emission or even negative emission. Okay. Some studies are also done, and we also did some, which talk about you might have heard about the tensile strength of bamboo, for which bamboo was oftentimes thought of replacing or working in place of steel. But bamboo also has got good thermal insulation properties, and that is also one of the good points to consider. Number 5, bamboo life cycle emission says that it is less than 70%. So that is a great point to be considered. And the last one is bamboo is renewable. So we are dealing with a subject, we are dealing with a material of construction, which is also renewable. Now, does that mean that we can use bamboo as it is? Because there are plenty of species of bamboo available around the states, and the National Bamboo Mission actually wants to emphasize on areas that grow bamboo a lot. But then what are the difficulties? Bamboo construction has been going on for quite some time, but there are some issues. So if you use bamboo untreated, it has a serious issue. Our area in Kharagpur is an area which has got a lot of white ant infestation. So bamboo is attacked by various kinds of insects. Infestation is a big problem. And what is the reason for that? The reason is they actually eat the sugar and the starch part of the bamboo. So there has to be treatment methods. We have to use treated bamboo. Now, do we mean to say that in all the traditional construction methods, they did not evolve any traditional practice of treating bamboo? Well, we have looked for the traditional practices and we found that there are 4 methods which are prevalent, which are traditional. Okay. Shankha, I will put the slides later on. I'm just giving an introduction. So we can
Okay,
stick
sir.
to the first slide now for now, and I'll tell you when to, change. So yeah. So the when we look at traditional methods of bamboo treatment, we find there are 4 prevalent ways of treating bamboo. One is water leaching. Water leaching is a very, simple process, very extensively used. We also found that in our peri-urban areas, it is basically submerging the bamboo in flowing water, but it is time intensive. It takes about 6 to 8 months. So when you submerge the water in flowing water, the bamboo finally gets rid of the sugar and the starch, and these are the items for which the insect infestation happens. So this is one. But is it a very easy way of treating and a very reliable? Well, I would say not so. Look at the second method, which we call the fermentation method. Fermentation method of treating bamboo. This is also a simple method where a compost with mud, a compost with mud, and we put the bamboo in this compost for 3 to 4 months. Okay. When we do so, the microorganisms convert the starchy and the sugary matter, and the bamboo becomes, as a result, less edible. So even this is another method which is quite often used, but again, it is not a very, very reliable, very scientific, and therefore we look for other methods. The third one is, you might have heard of the smoke and heat method. Now, that's a very common method of smoke and heat, which actually reduces the moisture content. It also releases the sugar, and it is quite effective, but it is again very difficult to maintain the same level of heat and smoke. So it happens that sometimes bamboo is unevenly treated along the length, right? So then that is also another method which has got some problems. The fourth method is to soak the bamboo in salt water, and that is, for about 3 months. Now this is
Your slides
effective,
are
but
not moving, sir. Sorry,
so,
sir, your slides
I
are
have
not
not
moving.
moved the slides yet. I have not moved the slides yet. I'm just giving the introduction, and I'll come to the slides in a bit.
Sorry, sir.
Okay. Okay. So this one, the salt water method, has got some problems. You must have seen efflorescence happening in your brick walls. Here also, when you soak the bamboo in salt water, the chlorine is harmful. So there, the sodium and salt, they can attack the metal joineries, which will eventually be the clamps when you do a bamboo construction. So, having said that, we find that the best scientific method of treating bamboo is to put it in a borax and boric acid solution. And that's what we did. We put the bamboo in a borax and boric acid. It is not harmful to the environment. It is cheap. And we do it for 7 to 2 weeks, 1 to 2 weeks. And the bamboo is treated very properly. So this is what is the background. We are not going in details of selection of the bamboo. We did an extensive study on the species of bamboo that were available in this surrounding, and we selected the bamboo that came up, that ticked most of the boxes. Okay, so now coming to the slide, as you can see that low-cost housing and bamboo reinforced mortar. This is what we are going to talk about. Professor, can we have the next slide, please? Professor Shankha, can you change the slide? Yeah. So the problem statement, which I already started saying, is that the conventional brick and RCC housings that are very common, they have a high embodied energy and they have high carbon emissions. You have, please go to the previous slide, Shankha.
So there is a lag. That is a lag.
No, but I want the previous slide. Yeah. So they have high embodied energy, high thermal mass, which is resulting in prolonged indoor overheating, limited suitability for incremental and low cost construction. So these are some of the problems. And therefore, there was a need for structurally viable, thermally responsive, and low carbon alternatives using locally available materials. Can we go to the next slide? I can share the screen if you're finding there is a lag from your end. Can we go to the next slide?
So there is a lag actually. I have.
So would you stop sharing and would I share?
Yes, I think that will be good, sir. I'll stop
Okay,
share.
so you stop sharing. Let me share.
Yes, sir. I'm sharing now.
Okay. Can you guys see my slide? Hello, is the slide visible?
No, sir.
No, sir. No, sir.
These issues are always like,
Still not visible.
ये तो लगाने के लिए वो कपड़ कैसा लगा दो कपड़ भाई वो कागज पे लगा दीजिए सीखलेगा नहीं कुछ नहीं रहेगा भाई पता नहीं चलेगा मेरा लगाने
Yes, sir.
अभी दिख रहा है?
Yes, sir. Yes, sir.
Yes, kindly make it full screen if possible.
Full
Yes,
screen
sir.
कर
Yes,
दिया
sir.
मैंने. I've done it from my end.
Yes.
So is it
Yes,
full
sir,
screen?
it is visible.
Okay.
Yes.
Okay, great. I hope there would be a lag if I share it from my end. So how did the project come to us? This is basically, as I said, is a part of an incubation project under the Global Housing Technology Challenge. You might have heard that the ministry had launched a Global Housing Technology Challenge in which there were some, cutting edge technologies from across the world that were adopted for new construction of houses and which would be speedy construction and which would also construct many houses. And there were some more construction technologies that needed handholding. So the bamboo construction technology that is happening at the moment or that we found required to be incubated, and that's how the project came to us. The major focus I can say is it's not just component level innovation. That is, we used to have component level innovations when we had innovated lintels or beams or door frames. It's not just component level, but it is more holistic. So from system level innovation integrated to a full building. So we wanted to do that, a full building innovation, and evaluations were conducted through full scale prototypes. So if we go to the TRL ladder, which I will show you in the end, TRL stands for technology readiness level. So in that ladder, it is from 0 to 9, and we are very glad that we have crossed technology readiness level 7. So I'll show you that at the end. So we did a full scale prototype, and another one is an ongoing demonstration structure, which is standing here in our campus. So before we jumped into the prototype development and designing and what we need to do, we wanted to find out what is the prevalent practice, what is happening with bamboo. And for that, we did some field work. We went to areas nearby Kharagpur. We also went to the missing community of Assam, Lakhimpur, and we also went cross-studied some of the constructions in Bihar where our incubatee had made some bamboo housing. So these instances we had studied. The learnings that we found from these studies are as I state now. One is some dwellings with bamboo posts had RCC foundation for safety, and there was a problem of rot between the RCC and the bamboo. I mean, that was the point from where the bamboo was prone to rotting. The second, as I was saying in the beginning, they were very vulnerable to termite infestation. And in areas like ours, where there's a lot of termite and white ant, there is a serious problem. So bamboo was not proven to be very, very suitable, untreated bamboo. Third was, it was also vulnerable to natural calamities like rain, storm, flood, etc. The next one we found was these bamboo houses did not have a proper lintel per se, a conceptual lintel. As a result, the walls had very small openings, so the window was very small, and therefore the light and ventilation of the indoor spaces was highly compromised. Waterlogging was seen, dampness we saw in some cases. So these were some of the issues we found that we need to solve. And then we went about designing. So what we did, as I said, we did an extensive study, field study and laboratory study of the different species that we get, and then we chose the species that came out ticking most of the boxes. That species we treated in a borax and boric acid solution. So each component of the bamboo component had been treated for 2 weeks before they were used. We also installed a bamboo shredding machine in our lab, which can shred within seconds bamboo pieces. So we don't need to do it manually. Next, the prototype concept was developed because that is how we want to make it foolproof. So a true scale prototype, 8 feet by 8 feet a square, built up area of about 5.9 square meters was built in our lab. It was built in the lab. It is already, it was constructed in the IIT Incubation Center under STEP. STEP stands for Science and Technology Entrepreneurship Park. So there we hired a space, that was our lab, and there we, as you can see on the right hand side, that we made this prototype stand in a full scale. The purpose, well, we wanted to validate the constructability. We wanted to refine the connection details because when we were doing the local survey, we found that bamboo was also prone to cracking from the connections. So the connections had a real problem. So we wanted to refine the connection details, and we wanted to compare alternative walling methods with our methodology that we were going to invent or develop. So here you can see some of the salient points, that the structural and envelope components of our prototype. So we were using bamboo reinforced concrete plinth beams with MS connectors. We had built up bamboo columns and bamboo reinforced mortar that we call BRM walls. Okay. We also had bamboo lintels and beams, bamboo trusses and lightweight roofing, and bamboo doors, windows, and jali. So these were all our structural and envelope components with bamboo. Now here you can see what were the dimensions. The BRC plinth beam design, that had a cross section of 250 millimeters by 250 millimeters. And bamboo reinforcement was used. We did not use any steel reinforcement. You can see on the right hand side, during the construction phase in our prototype, in our lab, we did that. So this was an integrated MS, we had integrated MS connector cast within the beam. Because as I said, we found that in the traditional system, the bamboo posts or pillars were getting rotten, or they were prone to rotting from the point from where they were emanating out of the concrete. So we wanted to integrate in our plinth beam a system of MS connectors. So this was motivated by, we had some prior experience of developing a school building with BRC, which was in place since 2014, and potential cost reduction was also seen. Okay. Next, I show you what is this base connector and the geometry that I'm talking of. Now we found that we did some experiments on wind loads and other different kinds of load, and we found that the major pillars should use multiple bamboo combs. Instead of single bamboo comb, we went for a system of 4 bamboo combs for the major columns, and the intermediary columns we did with single columns. Now these 4 column bamboo columns would have these base plates. This is a MS base plate that we developed, and this is one of the innovations that we are putting up for patenting. And this will solve the issue of the rotting of the bamboo, and this can replace one bamboo at a time in case you need to replace. So the base plate cross section was 240 millimeters by 240 millimeters. We had 4 MS pipes of dimensions, length 150, so change length, diameter 90 millimeters, and thickness was 5 millimeters. They were anchored by bolt length was 170 millimeters, and this enables axial load transfer and wind load resistance. So we found that this really helped a lot in terms of transfer of wind load and load transfer. Next, in this slide, we are trying to show you the built-up bamboo columns configuration. As you can see, this is from the real pictures. So multi-cum axial members, as I said, 4 bamboo columns, and then the cum embedded into the MS pipe was 150. As I said, the length of the MS pipe was 160. So it was secured in the MS pipe. The packaging tape, which is a waste product, we use the packaging tape to tie. You can see in the left slide here, this packaging tape we selected. Now, due to higher load capacity and the column typologies, we had the corner columns with 4 combs and the interior with 2 combs. So this is what is the configuration of the prototype. I hear some voices. Do you have any question here?
Yeah.
Thank you very much. So the walling systems, walling options that we evaluated included SRC wall panels, BRC wall panels, brick masonry, both 5-inch brick and 10-inch brick thickness walls, fly ash brick walls, and bamboo mortar walls. So we did a very extensive comparison, like you see the compositions, the rate per unit in INR, cost per square meters, and the sources. So we basically applied the DSR rates of 2019, DSR 5.22.6. So here, when we did the comparative analysis, as you can see, cost per square meters, you can see that fly ash bricks was coming the lowest and bamboo mortar walls was coming the second lowest. But fly ash also has got its own limitation, that is, it is available at the sources where fly ash is generated. So we struck out because we were concentrating on areas where bamboo is available and not necessarily where fly ash would also be available. So that was coming to 509, around 510 INR per square meters. Next, we are showing you here the bamboo reinforced mortar or the BRM wall panel, how we did it. We did a thin mortar matrix reinforced with bamboo strips. You can see the strips, and I'll give you the dimensions and the spacing in a bit. The bamboo here was acting as a distributed tensile reinforcement. Okay, bamboo's property is very similar to that of steel. We also used chicken wire mesh for confinement of the mortar, and this was, we felt, suitable for precast as well as cast in situ execution. We actually did both the types in our prototype, precast as well as cast in situ. Here you can see the BRM wall panel lab validated specifications. The panel size here I'm explaining is a 1 meter by 1 meter panel size. The bamboo strips, which we shredded in our bamboo shredding machine, they were 20 millimeters by 6 millimeters. The spacing in the X direction was 120 millimeters, Y direction was 40 millimeters. And one of the issues which bamboo poses is because of its shiny outer surface, bonding with concrete or bonding with mortar is a big issue with bamboo. This is something which people have been experimenting for some time. To overcome that, we used a Cicadur 32 LP gel and medium sand. This Cicadur we painted with brushes on the bamboo. And when we use this Cicadur gel, it creates a rough surface. It changes the smooth bamboo surface to a rough surface, and therefore the adherence was much better. So thereby we could also sort out the problem of adherence of the mortar with the bamboo cage that we have made. Here in the pictures you can see application of Cicadur. We are doing with a paintbrush, and then here you can see we are spraying of medium sand over the gel, and that medium sand gets stuck. Then bamboo cage with chicken wire mesh on both sides. On the bottom left picture you can see. Next slide, we show you the BRM wall panel precast versus cast in situ. As I said, in our prototype, we used both the types, okay, because we had an intention of, we still have the intention of doing it as a factory produced material. And so if it can be done, precast, then we can sell or we can package the bamboo precast panels, and then they could be bought from a shop. So we did both. The precast was faster in execution, 2 hours for 2 panels, and we had better dimensional control, obviously, when you have a factory controlled thing. The cast in situ was slower in comparison, and it was more labor intensive. It took about 2 hours for one side of the panel, and no additional finishing is, however, required. Here you see BRM panel size and cost optimization. So we try to do that, what should be the size and how do we do the cost optimization. So the final precast panel size came to 1200 by 450 by 50 millimeters. This size we selected so that it would be easy for manual handling. The cost decreases with increased strip spacing. So with 80 millimeters spacing, it is coming to 560. When it is 100, the cost is going down, and when it is 150 millimeters, cost is further going down to 491 rupees per meter square. So in the table below, you can see number of longitudinal and transverse bamboo strips and the spacing of longitudinal bamboo strips, the rate per unit, the total cost, and the cost per square meters. So here you can see they are hovering around the 500 to 550 rupees per square meter. So if you have 5 by 5, it is 564. If you have 4 by 5 is 527, and if it is 3 by 5, it is about 491. This one is showing the bamboo beams and the lintel system that we developed. Okay, the bamboo beam and lintel system. Here you can see that we have a double bamboo come used as the lintel. The horizontal bamboo members are connected to the columns. I already told you that there was a problem of bamboo splitting when the bamboo was at the joineries. So what we did was we used MS washers and we bolted the joineries, and that has reduced the scope for the splitting of the bamboo. So bolted connections were adopted to prevent splitting and improve reliability over nailed joints. So we do not recommend nailing of bamboo, which is a very prevalent practice. We would recommend the method of bolting it with using MS washers. Bamboo truss and roof system is shown in this figure. As you can see, where the base plate we had used for the columns. We have also used plates for the joineries and the trusses. So bamboo truss was supported on columns via these MS connectors. So we tailor-made these angles and we made these iron connectors. The MS connector was also at the ridge joint. Bamboo purlins were bolted to the rafters and designed for lightweight roof systems. So this entire thing is expected to have a lightweight roof. So what we were doing was not for multi-stories, but we were doing it for a single story. Okay. So you can see the joinery details as we have done. Here is the roofing material selection. Now we have got choices. We had choices ranging from galvanized roofing sheet, which is very common in these peri-urban areas, to galvalume, to plastic roofing sheet, to bamboo roofing sheet, to thatched roof, and to halved bamboo roof. So, and bamboo plywood. So we have done a cost per square meter also, where you can see that galvalume is coming one of the cheapest. Okay, the blue one you see in the picture. So finally, for this project, we have gone for galvalume roofing, which is basically an alloy. And but you have got the cost comparisons of all the other roofing materials. Now, for making this roof, for doing some passive thermal strategies for the roof, we thought that we can do a little bit of green roofing technique. So a bamboo mesh mat was placed over the galvalume sheet, which can support climbers. It's very simple. It is also very prevalent, and this galvalume roof can have these creepers, which finally brings down the thermal load. So its intention was to reduce the solar heat gain, and it also has a combination of lightweight roof mass. So it's great. Other than that, we did a few more inventions. For instance, we created, for indoor livability measures. What I said in the beginning was we found that the existing buildings had very small openings, and the indoor condition in terms of light and ventilation was actually poor. So we wanted to enhance that. And for doing that, we did a few things. Here, as you can see, we have a proper lintel, so the window sizes have gone up. We did bamboo windows, which were mounted on pivots. So these windows on your left-hand side can actually rotate over the pivots. And that was quite an innovative small piece. Here you can see it has been rotated right angles. And these are some of the, using wastewater plastic bottles we were using through holes in the roof to give natural light into the interiors. The waste plastic bottle was using like a skylight. And here we are showing you some pictures of, over the galvalume, how we wanted to create a layer of green roof that would further reduce our indoor living conditions. We also had a higher ceiling in the central spaces, and that would increase the indoor livability measures. I will stop present, and I will now request my colleague Professor Shankha to join and talk about the lab results that we conducted here. Shankha, can you hear me? Do you want me to stop sharing?
Yes, sir. Yes, sir. Yes, sir.
Okay.
Okay. Thank you, sir. And thank you, BMTPC, for giving us an opportunity to showcase our product, which, as Professor Chattopadhyay said, couple of years we are actually trying to establish it as one of the replacement material for Pradhan Mantri Awas Yojana Gramin. Bamboo is one of the suitable green building materials, as Professor Chattopadhyay also very nicely described, that it required a very less amount of energy, and actually it is a carbon negative product. So before we do something, suppose a particular material when we talk about, we need some kind of standardization. So you have to first make some kind of a test and then we need to see what is the test result, and based on that we have to take some kind of strategies. So I will come to the PPT little bit later. So I will just now want to show you some of the test result which actually give us some kind of a direction to how the bamboo can be used, and what to do and what not to do. So let me share one of our report that was definitely, I mean, is in the domain of BMTPC. So this is that. Can you this report is visible? It is a PDF report. Is it visible?
Yes, sir.
Yeah. So we actually initiate the some kind of our initial experimental innovation in the civil engineering department lab. And as Professor told you, we have initially had a lot of study about the different species of the bamboo which is available in and around South Bengal, and those are actually taken from the different market, not from the villages, because those are actually has some kind of a commercial value. And those particular bamboo species, these species which is available plenty here, we first check about their what is the tentative height, what are the tentative that particular thicknesses and all. So these are the some of the things we studied. Then what is the internal node length? Node length means suppose this is a bamboo something like this, so there are some kind of a nodes. So these are the some joints. So what are the typical type of node lengths and all that all we have studied. So that is the initiation, and then we did some kind of a treatment, as Professor already told you. Then we started testing the bamboo in various load conditions. First of all, we have tested in for the tensile properties, because this is the bamboo is actually a long fiber. So fiber has an enormous strength to take care of the tensile stress which is developed in any kind of structural material. So we have the UTM, the universal testing machine, and from in that testing machine we have prepared. You can see this particular the figure 4.6.3c, where a small species has been tested against the tensile load. And if you see all the 5 type of the bamboo, the species, we have actually come across with 10 Newton load, and we see what is the tensile strength of that particular species and all, which gives a kind of a tensile strength is in and around 80 plus to 140 megapascal or so. Now, which you may say that it is little below the steel, but due to we are not actually using for a very long span member also, for housing whatever the span length and all, which actually can be accommodated with this particular tensile requirement also. After this particular the tensile, which was our good finding, we also tested for that in a compressive property, because compressive property is very important. As you understand, it is a fiber. It may have a good tensile property, but under compression the fiber may dislodge, and they may disintegrate. So that is another issue. So we also tested it in the compressive machines also, and also we found a negotiable kind of the loading or the stress which was found in compare with the tensile strength also. So if you compare this mean ultimate compressive load, which is again 63 to 154 or whatever, and also with this tensile, it is something like something like a steel, which is having the both good strength in the tensile and the compressive in manner. So this particular the result will now initiate that yes, we can actually use the bamboo strip in long fiber direction for any kind of the structural member. So if you see our prototype housing that Professor Chattopadhyay has been shown, we have two such members where we can actually going to use it. One is the plinth beam, where we have not used any kind of a reinforced steel reinforcement. All are the bamboo reinforcement. Even the stirrups are also with the bamboo. So we can use that one. We can use the bamboo without any hesitations, because it has comparable good amount of the compressive and the tensile strength. The next one is our bamboo reinforced mortar, the BRM wall, because the BRM wall, maybe it is a wall, it has to actually design for its own weight and also some kind of the transverse load because of some kind of a high wind or so. So for that, these two members can actually accommodate your the bamboo string. But next, when we go for our truss member or those four bamboo column member or so, it is an individual bamboo we have to rely upon. So whenever we have to go for a column member or a lintel beam member, or maybe a beam or a truss rafter or the tie beam, then we have to check the straightness of the bamboo. Because the bamboo is a natural the material. It cannot be an industrial product that will give you a perfect straight line or that kind of a prismatic kind of a geometrical shape. So we have tested that what is the deviation. So this is, you see the zero or the mean point or the mean line, and we have tested that how much it has been deviated from this particular mean line after certain distance of maybe 500 mm or so. So both from the, suppose this is the distance in the x direction, this is the distance in the y direction, z directions also, and if you take this direction as a z-axis and if this is as a x-axis also. So deviations are there, definitely deviations are there. This is under a over a length of 6 feet, which is 1800 mm. So within under a 6 feet, there is some visible deviations are noticed. But all the bamboo species are not so much. I mean, from the component point of view and the different species point of view, that the straightness index or the straightness property is not equal for all, and so we have to actually choose those bamboo which is having a higher straightness property for those long members like tie beam, rafter, and the four bamboo column systems also. So this is the test which has given us some kind of a confidence that out of the 5 such the species which we can do for, which we can go for those kind of things. Then you see we actually go for an axial buckling of a single bamboo and also the axial buckling of the 4 bamboo component. Why buckling is required? Because we are not expecting that much amount of high axial load from the top, because it is a GI sheet or maybe some kind of a thatch roof or maybe tiles or something like very local or vernacular material, which may not have that kind of the heavy loading on the bamboo. But this area, the South Bengal area, or maybe this Odisha and South Bengal, this area where the bamboo and the mud bamboo is one of the local material for the building construction, and we want to replace it, this area is prone to cyclonic storm. And whenever there is a cyclone, the behavior of the column will be definitely will be different. It will not going to take only the axial but also the transverse kind of failure, and then the buckling will going to come. So from that angle, we actually ensure that those straight bamboos which will be act as a monolithic column, or maybe 4 bamboos will act as a monolithic column with that particular packing strip also should be perfect from the axial buckling also. So you see, we got some kind of a horizontal. So in this particular, again, we go back. In this particular experiment in our lab, we actually increase the loading from the top. And as in when it is increasing, there is a deflection we will see. One is the horizontal deflection, which actually talked about the buckling, and there will be definitely a vertical deflection, which will be a little bit smaller in nature. So you see this vertical and the horizontal deflections are noted. And if you see this particular graph, this graph is very interesting because you see the vertical displacement, the lower one, the vertical displacement point of view, this is almost like a perfect straight line. That what does it mean? As and when applied load is higher, the deflection will be higher, and that is very natural and very logical. And it goes with a straight line. That means it's under the elastic limit or so, right? It is not going to abruptly change the linearity. In the horizontal displacement, if you see, initially it is linear. Initially, after certain distance, it is linear, all the species, and then it goes with some kind of a non-linear. So this is the non-linear NL, if I write. So this part is the non-linear. So we can say that after certain load, maybe around 25 kilonewton or so, this particular the behavior of this particular bamboo as a column in the horizontal displacement point of view is elastic in nature. So we want to catch that particular point. Till where? I know it will going to fail somewhere, but in like any other material, steel is also going to buckle, but where it is going to buckle, it is very important to know. And that is why probably whether I'll go with a one single bamboo or two or four that will be going to share the load, that is very much important. So we found something like 20 to 30. This is the range where it started become a little bit non-linear. And as and when it is non-linear, you cannot predict the behavior properly. So better restrict yourself within that. So this is, again, we got some kind of idea that how it can be placed also. And these are the some of the pictures when we have tested that one in our lab. So it is the failure mode of the single bamboo. After that, axial buckling of the multiple, that 4 column, we have taken 4 column. There are the genesis of using the 4 column is that in between this 4 column we can actually plug in the bamboo reinforced the panel, that mortar panel also. Okay, that was the first the biggest benefit of that particular 4 column system, and also that will help us being tying in a proper way and symmetrical way, and the load is actually distributed into 4 hubs also. So now this particular the bamboo is the 4 column bamboo for typical bamboo species. The 4 typical bamboo post has been tested in various level. We have put in some kind of a the spacer, which is again a bamboo, small bamboo logs like this, and we tested for the horizontal and the vertical displacement. And with this particular, we can actually find out what is the mid-span deflections also. And we notice that it has jumped the value, which was initially we saw the deflection is going abruptly with the non-linearity. Here we are going to have almost like 150 to 200 kilonewton with 4, of course, with 4. So now we are very happy that yes, with 4, the linearity goes about 150, 175 or something like that. And with different type of packing tape we used also 3 different type of wire kind of a thing, and then we use the packing tape because both are having the good argument with the load and behavior. Finally, we also test. So these are the tests what we have. There is another test I will tell you a little later. And then we jump into this BRM wall testing. As Professor Chattopadhyay told, the mechanism, how we prepare it with the Sikadur and all. And then we started testing it in the lab, making some panel and putting some 4 pointed load in the uniformly in the 4 different quadrant of the particular slab. And we finally go into some kind of a value of the ultimate load strength and what is the maximum deflections also. And these are the BRM PW and CW. Those are the cast in situ, and this is the precast. PW stands for precast, and the CW is the cast in situ wall, cast in situ. The panels also both we have tested, and it has been give a kind of a similar kind of ultimate load, ranging between 30 to 40 or 43 or something like that. And this behavior of the deflections is also under load is also perfect, and it follows the typical concrete or some other kind of a material also. No such of kind of sudden failure or those kind of things has been noticed, which can be thought of for applying for kind of the wall. And then what we did is, and this is the way we actually go for the load test, that is the setup for the load test for wall panel. In this, what we did is this particular, the earlier one, what we did is that it is for this 4-point load. There are 4-point load has been, if you see in this particular jack, this is the loading jack, this is the loading platform, and there are 4 contact points, and those 4 contact points are putting up some kind of a 4 loads, which actually we can say as it is a kind of a uniformly the pressure load on this particular panel itself. The next one, what we have done is that we have tested with a single load point, and we use two different type of the wall panels with different spacing, as professor already told you about the x-axis spacing and the y-axis spacing, 80 mm, 100 mm or so. And this is CWM, W/CWM, that is with chicken wire mesh. So with chicken wire mesh we did, and also without W and O, that is without chicken wire mesh also we did. So we see that what is the change in the result. There is no such significant change in the result. Result is almost like the same way it has been built up, and then it is going to failure or so. Chicken wire mesh cannot contribute that kind of a enhancing the load carrying capacities also, that we understood. But chicken wire mesh we have been still put forward for our this element design or this BRM, because there are two reasons. One, it will furthermore enhance the adhesibility or the bonding between the two layers of the mortar. That is number one. Number two, a layer of chicken mesh in the both the side will definitely allow us to give some kind of that movement, that thermal movement in day-night temperature variation. When there is a day-night temperature variation, there will be some kind of expansion or contraction in this particular material or this particular wall panel. So that particular can be taken care of by the both side, this the chicken wire mesh. But introducing that one doesn't help us to enhance the strength. So these are some of the tests what we have conducted. Now let me go back to the PowerPoint presentation once again, where we are somewhere here probably. So as Professor told you, is it visible in the full screen mode? The PPT?
Yes, sir.
Yeah. So as Professor told about that indoor livability measures, and then we have provided some kind of the ventilation also at the top level of the roof level, where that stack effect can be enhanced. We did it those kind of the connections, joints, and all those kind of experiment that I have just now told you, and those load displacement diagrams and all those. Yes.
Because your PPT is not coming.
PPT is not coming.
Is a previous report which is still showing.
Okay, just a minute. Sir, is it visible now?
It is coming. It has not opened yet. Yeah, now it is visible.
Okay. So these connections and the wind pressure and all those load and these things we have just now discussed. These are the again those are the load and another interesting test that the data was not there in the report, or maybe that was latter has been added. So you have also tested for the connections. Because as you know, again, if I repeat that we are here in the South Bengal is prone to cyclonic storm also, where we require a lot of connections, and that is why perhaps we introduce those gazettes and the connections by virtue of the steel pipes and the gazette plate. Because connection is very important. So if I say something like, suppose if I actually say, it is said that in cyclone cases we have to actually go with the ABCD principles. ABCD principles, what is that? A is anchorage. So anchorage is very important. You have to ground it, the thing, otherwise things will wash out or blow out. So anchorage, that is why we introduce the pling beam over there, and there is a sufficient amount of anchorage in the foundation. The B is the bracing. So we require those kind of a bracings, and those kind of a bracings are required when we can go for a little bit of long span trusses also. So trusses, we go for the inclined bracings or the tie or the other members also. The bracings is required because that will distribute the load properly. C is the connection. Connection is very important in the wind load. So that is why we do not actually compromise with the connection. And the connection, if you see, the one connection is here. It is a truss connector. And the second connector is the truss to the column connector, which is this four the pipes, the steel pipes, and there is a base plate, and also there is a similar the connector at the base with the foundation. So connection is very much important, and that is why we feel that maybe a little costly, because we have to introduce some strategical locations, some kind of pipe, steel pipes and the gazette, but we should not actually leave that. Connection is very important. And whenever we go for that kind of connection, we did some test also. So what is, as professor told, that don't use nails, use bolt. So under the bolt connection, under a tensile kind of a scenario, what will be the capacity? So bolt is good capacity. Bolt will not going to shear it off for the break, but definitely there will be some kind of split and all this side. The split will be there. The split is actually noticed somewhere here. So we tested that one. What should be the spacing of that particular bolt and all these things we have negotiated with the particular thing. So the anchorage, bracing and connection, and the D stands for the detailing. So whenever we go somewhere for some new kind of connections, or so we have to go for the detailing. The what should be the height or the length of that kind of connection. What should be the typical length of this typical length of this? What should be the typical length of that? Is it 150 mm is okay, or maybe you can go reduce to 120 mm or so? So that type of detailing is required. So for cyclone the resistance structure, we always go for this ABCD, the fundamentals. So we also employed this ABCD fundamentals over here. We then go for the thermal analysis. So whatever we have just now discussed is the structural the properties and analysis. We also do some kind of a thermal analysis, computation, few of them by software and few of them by hand computations also. So we took as this particular area as a warm and humid climate, and this is the Sastik sign like building was our the building which we have constructed in the STEP campus, and we take different orientations, the C1 and actually there are two type of the cases we have taken: reinforced bamboo construction and the conventional brick convention, and we have oriented into different the orientation 0 degree with a particular decam and 45 degree, and we got this particular you can say signature, the thermal signature image, where in the x-axis, if you see it, these are the January, February month, and the y-axis is the day. So from 0 to 24 or something is there. So we did it for the 24 days or 25 days of a month, keeping 4-5 days because there may be some kind of a holidays or something like that per week or whatever from that point of view. So this actually gives you the pixel of 12 multiply 24 pixels. So our data, and if you see those data and if you see this red color one is the stressful areas or stressful time where the envelope heat gain is maximum. So if you see visually the case one bamboo construction set, bamboo the construction, that is our BRM one, and the conventional brick look alike, but the thing is that the conventional brick is of 250 mm thick, but in the bamboo construction we have actually used for the 3-inch 75 mm 3-inch. So if we have a potential amount of thickness increment, definitely the red colored zone should be minimized with respect to the case 2. So we got some kind of the conclusive remark from this the simulation. Simulation shows the distinct comfortable temperature between 14 degree to 28 degree, mostly on the mid-October to the mid-March, this zone, which is comfortable zone or comfortable month. The temperature fluctuation due to the seasonal changes are quite similar that we have already discussed, but traditional brick RCC construction exhibit high peak in the summer temperature, whereas the brick and RCC will have the high thermal mass when we compare with the bamboo structure also. That is one of the reasons that it can store lot of amount of heat. That is why maybe the spikes are also very high. If I just want to see what is the surface temperature of the brick, surface temperature for the brick RCC construction. So the traditional brick RCC construction displayed an early rise temperature, as in because it has been kind of a highly thermal mass kind of a scenarios also, indicating the prolonged period of the indoor cooling requirement. And the brick panel, the structure demonstrated a gradual temperature shift towards the day, and that will be because of it has been having a kind of a low potential of storing of the heat also. So this particular the comfort finding we have to now relate, because our first attempt to make this particular building low cost. So that is why from the structural point of view, 3-inch thickness of the BRM panel is good enough for our structural protection from the wind or anything like that. So we didn't increase that one. As in when we increase that one, structural protection will be the same. It will increase the cost, but on the other hand, it will decrease the thermal load, or it will make more comfort. So comfort, we put it in the second bench. So that is why we keep still the 3-inch. We go with the 3-inch kind of a scenarios also. And probably we will think of some kind of a other way around how to insulate that one in the future. We have something in our mind. We can go with some kind of the EPS kind of a solutions also. So that will definitely increase the cost a bit, but definitely decrease the indoor environment, indoor ambient temperature also. Now, whenever you ask me something that how good it is from the energy point of view, we have to say two typical point. What is it? It's embodied energy. That means when I'm going to construct it, what is the embodied energy of it? How much material I'm actually using for this construction? And each and every inventory of the material has actually have some kind of a energy contributions or the energy footprint. So I have to talk about that, and also to talk about some kind of the operational energy analysis, that after construction, when it will be operated for its whole life period, how I'm going to use, what is the energy use because of this envelope parameters also. This particular computation we did in normal the Excel and all those kind of a thing. So you see, this is a very interesting find out, where we have compared again two type of building. The green, the bars are of the bamboo-based structure, which is our building building, and the other one is the RCC brick structure. And you see for the foundation system, and there is a table also. You see the comparative analysis of the foundation system, the wall system, and the roof system. Always these green ones are lower than the black ones. So that means that it has a lower footprint of the embodied energy. So if you see, and if I actually divide that by the built-up area, we keep the built-up area same, and the total embodied energy is 232 gigajoule, and this is about 600 and almost 700 gigajoule, and we keep the same area. So we see that the energy footprint normalized to the energy footprint is gigajoule per meter square is 1.25 for the bamboo structure, and where it is 3 point almost three times is the impact is the impact.
आप हमको नेक्स्ट आईडी भेज सकते हैं मैडम?
Excuse me, can you switch off your terminal, the voice terminal, or mute yourself? Can you please mute yourself? So next is, if you see,
Sorry, Professor Bhattacharya, this is Pankaj Gupta. May I request you to wind up in maybe next
yes,
5
yes,
minutes? So
2
we
minutes,
have
2 minutes.
10 minutes for the question answer also.
Okay, 2 minutes. So also we did it for the carbon emission also. If you see the similar way, it will see the almost 3 times less with respect to the RCCs also. So this is the bamboo and the operational energy profile. You see, it is also very interesting. So what we did is that it is the first one, which is the bamboo. The blue one is the ambient temperature, which is this one is the ambient temperature. I'm just going to finish within 2 minutes. Ambient temperature. Then the red one is the indoor temperature of the bamboo reinforced panel, and the indoor temperature of the brick wall. If it is normal brick wall, they are going with a good negotiation. There is no such of difference. Definitely there is a damping. There is a damping which is given as a decremental factor, like which is normally both are the same. The peaks are little down, but the brick wall is having little bit of higher time lag. That means it is shifted the peak towards 2.5 hours to 3 hours, whereas the bamboo reinforced panel shifting only 1.5 hours, 2 hours. It's because of this thermal mass. It is thin actually. But we have tested, not tested as such. I mean, we have actually computed, if I use a bamboo reinforced panel plus extended polyester insulations, then a drastic magic we can see where the damping will be almost like 0.8, 0.9 to 0.45 or 0.55. Huge amount of damping will be there, which is a peak reduction of the indoor and outdoor, and also it will increase the time lag. So it will be shifting to the peak from the around 3 o'clock in the outdoor to almost about 8 p.m. in the evening or so. So this we have computed, we have not tested by virtue of our computation equations and some kind of modeling we have tested. So we did it for our lab, for our the site, and this is that particular building where we did some kind of, these are some of the component of that particular thing that in the 3D. So we did also some kind of technology designations with the local villagers. We did a workshop. We tried to understand their problem also, and they also give us a lot of feedback after this particular workshop, and they actually wholeheartedly welcome this particular product. And these are some of the workshop photographs. The first one, Professor Hemanti Banerjee is presenting, and these are some of the participants. And these are that workshop. And I request Professor Chattopadhyay to end this particular lecture by this TRL level slide and some concluding remarks, sir.
So your slides have not moved from BRM wall panel. In my screen, I see the BRM wall panel.
Sir, it may take some time, maybe.
No, not moving. They were moving before, but now
Sir, is it visible now?
no, it is BRM wall panel operational energy analysis. It's stuck in that.
Okay, sir, just a minute.
So maybe if some issue is there in forwarding the slides, maybe you can give the concluding remarks and then we can wind up.
Yeah, I think so. So Shankha, you can finish it up. Now the slide has come. You can put it in the full
Yes,
screen.
sir. This is in the full screen. Now, sir, please, you can go through this particular slide, TRL level slide, and conclude from your end, sir.
So participants, as I was telling you, that from 1 to 9 is the TRL level. So when you have a basic technology research, it is at the level 1, then research to prove 2, then it goes up. So when the technology came to us for incubation, it was at a very primitive level. Though they had tried out making some bamboo houses, they were not able to identify what the issues are. And there were several issues. Like we went to Lakhimpur, we saw the one in Bihar, and there were several issues. And I'm happy to say that in a very systematic way, we have been able to identify the issues, solve the issues, innovate some of the components, and our prototype, as well as the actual building, which is a community center for the people around. It is about 1800 square feet. It's up and standing, and it has withstood the few of those calamities that came, which created havoc in this area. And our building is proving to be very successful. So we have had workshops in that. So I'm very happy to say that we have crossed the TRL 7 and we are into 8, where system commissioning and system operations are the ones. We are getting very good inputs from some people who matter, and they're showing keen interest, and perhaps this technology will go in the wider domain very soon. So thank you very much indeed for such a wonderful participation. I can see that we had at one point about 200. Now I see 147 participants, which is a very good number. Thank you very much indeed. If you have questions for both of us, we are here to answer.
Thank you very much, Professor Chattopadhyay and Professor Bhattacharya. If before concluding, I would request if somebody is having any query or any questions to the professors, they can ask directly, I think. Because in the chat box, I'm not seeing any specific questions. So many names are there. I'm not able to comprehend whether some questions are also in between or not. So I would request if somebody is having questions, they can directly ask.
Hello, Jai Jagannath. I am Tara Prasad Dhal, architect from Odisha, Bhubaneswar. So I was going through your presentation on this. So is there any IS code for practice for bumper enforcement and all?
Sir,
We have applied PAC.
Sorry, sir, please repeat.
Shankha, you wanted to answer. Come on, go ahead.
actually,
So
there
is
is
there,
actually there are certain specifications is given in the NBC, and there is a specification which is there available in the IS code, but that doesn't talk about any kind of the structural strength and the modulus of elasticity and the process as you can actually replace steel also. Because it is totally species dependent, and how you actually work with it by virtue of some kind of the seasoning and this kind of the other kind of chemical seasoning or so. That it depends upon that. So specifically, a typical code of practice is very difficult to, or it is not available for any country now at present.
But you said that we can replace the reinforcement bars with the bamboo.
Yes.
Stirrups, bamboo stirrups, and
Yeah, that is why
so
we follow.
yes. So you have already presented your research paper on this. But how it is more useful,
No,
particularly so far. So
हमरा
far,
बोल रहे थे कहा राजकुमार आप हमारी तरफ से खेलिएगा तो बोले पार्षद
yes,
को
Pratim.
भरसक करके खेलिएगा तो हम तो कार्यालय की तरफ से रहेंगे
Please switch off your mic. Lalganj, Mr. Nazir. Mr. Nazir, please
हाँ
switch off
प्रैक्टिस
your
करने गए थे
mic.
आज बोले ना गए थे अब भतीजा तो हर
Mr. Nazir Ansari, please switch off your mic.
yes. See,
Yeah.
that is true. We have used it as a replacement of reinforcement in small scale building, like building where the span limitations is there. And when we use it, because we have tested those particular bamboo species, 5 of them which is available, and based on the test data we have replaced it in a small span buildings. In some of the buildings in our campus also we have did it. In some of the some of the security booth and all those. One primary school, which was done beforehand from one of our Professor Damodar Maiki, and from in our case we tested it and we found the compressive and the tensile stresses in good agreement, not exactly as the reinforcement as it is in the steel. So we can actually apply it for our foundation, blind beam, and the BRC panel. But for the wide use of it for a long span beams or so, we have to wait. As it is for the rural housing, we can definitely use it for that. For that purpose.
So, first of all, thank you, Mr. Professor Bhattacharya and Professor Subrata. I am Krishnamohan Sharma, Chief Operating Officer of a German company. My, one thought came that how we can utilize bamboo in the precast setup, because I am heading one precast engineering company. So we make precast volumetric houses in the factory and this. So is there any way we can, supplement these two things, or how both things can go together, or otherwise what are the places where we can utilize this bamboo housing? Especially load bearing comes into play, and the thermal property, as you said, it was quite good and impressive that we are saving energy into this. So is there any probability that precast industry and bamboo, we can sandwich something? So that is my question to both the professors. Could you unmute, sir?
So thank you, Mr. Krishnamohan. This is what we are also going to do. And that is why I just said that we have applied for the PAC, which is a Performance Appraisal Certificate. So once through, our point is also to commercialize it, and so that you can have the bamboo reinforced mortar panels. As you get tiles in the market, you get boxes of tiles and you can fix them up one after the other. We intend to create those bamboo panels as precast element which can be bought from the market, and with very easy manual of fixing them one over the other, one can erect a community center or a house under PMAY, which is a small house. So we do have that in mind. I would be very interested if you are in touch with us, write to us, and we can develop some concepts together.
Okay, that would be nice. I would be happy to share the coordinates if you have, or I'll send my business card, and how we can do something, on this front. That would be nice. So
yeah,
that's certainly
Mr.
we can
Kishan
do.
Mohan,
Yeah.
Mr. Kishan Mohan, this is Pankaj Gupta from BMTPC. As you told that you are into 3D volumetric precast construction, I just came to know.
Yeah.
Could you tell me which companies you are representing? Because we are in BMTPC. I hope you are aware of BMTPC and the activities we are doing, because most of the new technology companies we are already in touch with, but I could not get the name of your company.
See, sir, BMTPC, I used to interact with Mr. Shailendra. Shailendra is there, many forums we meet with him. And I am
Uh-huh.
representing a German MNC that is Follett. In India, we call it Wallert, Wollet.
Okay.
And we are in Greater Noida. There's a global manufacturing hub here. We supply to Kharagpur
Okay.
from this place. And I will certainly connect with you also, sir.
Uh-huh.
If you
Yeah,
can give the
definitely.
number,
I
I can
would,
share my register.
yeah, maybe I have normally Dr. Agarwal used to have a meeting with the new companies when they are coming, but somehow I don't remember if I have met you or any person from your company. So I would be happy if you can connect with us sometime in near future, and maybe we can work out something. And just would like to know how your what is your product and how you're doing the things.
Okay, certainly, sir. So I'll get connect with you. And last year there was a last year only you conducted a seminar. I was also there in Delhi. The latest technologies on this. Professor Agrawal was there in some of the place.
I would request you to share your number or email ID in the chat box.
Okay, okay. I do it right away, sir. I share my
Thank you.
contact.
And moving forward, because it is taking time, that's why I told you just to share your number. And
Yeah.
if any other questions to professors?
Yes, I have a question. Can I?
Yeah, sure.
Thanks.
Yeah, thank you. Dr. Praveen, this side from Triple IT Hyderabad. I have a question to Professor Subrata Chattopadhyay, sir. How does this variability in bamboo geometry and the material properties especially affect when we are using in the structural design?
Okay, I think Professor Bhattacharya had talked about the tests that we conducted for the straightness. Okay, and we actually selected the ones that came up with very good results. Because it's a natural product, it will never be very straight. But we did the straightness tests, and those bamboos that were giving us very good results, we chose. So that's how we overcame this problem.
Okay, okay. I have one more point. See, we have different type of housing systems when we talk about the low-rise masonry, earthen constructions, and at the same time reinforced concrete alternatives. So what type of housing systems out of these are most compatible with the bamboo reinforcement?
Okay. So for this, Shankha, do we have a picture of our community center readily available? I didn't see that in the slide. So I would till Professor Bhattacharya looks for the picture. This community center of 1800 square meters that we have constructed, one of our ideas was that people should not feel that it's a low technology that we are trying to show them. And we also wanted them to be proud of it, which we felt they were, because this building looks like a permanent pakka structure. It doesn't
Yes.
look like a bamboo structure, right? So that was one of the things which we had in our mind, because whenever we were doing the studies of bamboo housing, they were like typical bamboo house where you see the bamboo elements and the bamboo walls and everything. But here bamboo is used as a reinforcement. The only bamboo part which you can see is the columns, and which also very aesthetically we have done with four come together, and the trusses. But the walls look like proper, brick and mortar or concrete walls, and the building itself. Shankha, did you get some picture of the community center?
Sir, just a minute. I think.
So if you can show it.
So in the meantime, I'll have one more point. When we talk about this bamboo reinforcement, the bond behavior also plays a very important role. So how does this bond behavior between the bamboo and the surrounding matrix, it can be concrete, mortar, or the earthen material, differ especially from that of the steel reinforcement? If you could highlight a few points on this, that would be quite helpful.
We did a fair amount of study on that as well. The bonding you are interested in, right?
Right.
So when I said about the difficulties of using bamboo, I used one, which is like treatment of bamboo is necessary, otherwise it is prone to infestation. And the second I mentioned was because of its smooth surface, the bonding between
Yes.
concrete and bamboo is a question. And we overcame that by roughening the system, the surface, by painting a coat of sikadur. So that
Okay.
sikadur also attracted the medium sand. So we sprayed medium sand onto the bamboo, which was painted with sikadur. And now the surface is ready to hold the mortar.
Okay.
That's how we overcame this. Yeah.
So the prior treatment is very much necessary in order to have the proper bond.
Absolutely. Yeah.
Yes. Yes. And my last question, it is especially related to the model. Are there any established design models or constitutive relationships which are available especially for bamboo reinforced structural element? Suppose if I want to model in Abacus or any other finite element software, so I need to pick up some material model. So that was the point which I wanted to know.
Good. I think Shankha, would you like to answer that?
Actually, am I audible?
Yes, sir, you're audible.
Actually, we are in a if you say from the finite element model point of view, or the kind of a, so straight geometric model is possible as it has been some kind of the load testing and the tensile testing has been given to us, but kind of a very oftenly in a very pointed load or those kind of phenomena when there is some kind of a instabilities or so, we are still not very much sound enough to go with this kind of testing also. That is why we are typically thinking of this particular replacing reinforcement in the foundation, plain beam, beams, lintels everywhere, basically for low span housing unit of G+1 or something like that. Not at present with this all those kind of
like just to expand, because I mean to ask these specifically the material model, like in Abacus we have a model called concrete damage plasticity model, right? CDP model. The same cannot be used for bamboo reinforced construction. So do we have any specific material model related to it, especially simulating the stress strain relationship with respect to the bamboo reinforcement in particular?
No.
Or still the research is undergoing.
Still that particular area, the still in our lab still research is pending on the.
So my last point, what is the current status of the design code or a guideline, especially for bamboo reinforced construction in India and internationally?
This is internationally still we have not found anything. In India, yes, as I told earlier that our national building code has a chapter in it. We had a IS code in yes, it is there, but just to guide you to do some kind of a wall panel or some kind of a joinery, some kind of a packing or benching, those kind of a things. But those are with some kind of, the thumb rule based kind of a thing. So we have to come out with that. So we have to, you have in India almost like, I think 120 plus species of the bamboo. So it is very difficult to take care of all these things and put up in a particular course. So
thank you, Professor Bhattacharya, and thank you, Professor Subrata. Thank you for your time. It was really a wonderful presentation. A lot to learn from you people. Yeah.
And we would love to be hearing from you more. Praveen, you can write to us.
Sure, sir. Sure. Actually, I'm affiliated to Earthquake Engineering Research Center, and I mostly work in structural earthquake engineering. So masonry, bamboo, it's very close to me. So that's why I have few queries related. Thank you.
Any other question, please?
Hello.
Yeah.
Namaste, I am Samir Jamate from Tripura.
Yes.
Bamboo reinforce and concrete reinforce, which must the costly is actually we have see the in notice our places also. So we but it's a pick up the choice in people the concrete. This is the RCC is the almost like, but if they rejected the bamboo reinforce, why this is the issue?
So there is the picture coming up. Shankha has found the picture. Shankha, did you get the question? Actually, it wasn't very well audible to me.
Can you please repeat the question? I mean, this is a bamboo reinforcement. Why it is bamboo reinforced? Concrete
Yes,
is not
bamboo
popular.
reinforce the is our size. The bamboo is the available, but if you
Yes.
work, if you construct, but costly is the high, then people public is the choice the concrete. Concrete is choice. So that is the how can the reduce the cost. This is the main fact, and the space is also the there are lot of our spaces and Balkwa like Tulda, Notuns also better to the we have the terraces oliveri also. So that is them then point.
No, as we have seen in our Bengal, South Bengal area, if I replace a typical amount of the beam or maybe a slab with normal RCC, which is reinforced concrete, with steel reinforced concrete, we replace with the bamboo one is much cheaper. Bamboo one is much cheaper.
Hello.
Hello, yes.
Sir, I'm Manoj Sharma from Ujjain. What is thermal effect on bamboo in comparison of steel? Because the cracks are developed after through 2 or 3 seasons.
Yes. Your question is not very clear. It is thermal crack.
Thermal effect of steel and bamboo is differ. The expansion of steel is more than bamboo.
Yes.
So cracks are developed after 2 or 3 seasons.
Yes. In our reinforcement, the steel reinforcement.
Yes, sir.
No, I didn't clearly. Can you just clearly narrate your question? I mean, I don't understand the question.
Sir, expansion of steel
Is higher. Yes, it is higher.
is more in comparison of bamboo.
Right.
So the mortar, we are laying mortar on the bamboo or steel. The expansion limits are different.
Right.
So cracks are developed after 2 or 3 seasons.
For bamboo or for steel, cracks will develop.
The comparison of both.
Bamboo.
Bamboo structure and steel structure. What is the difference? Which is faster crack?
The first of all, if you see, we are use BRM, not C, the bamboo reinforced mortar, right? So in that particular material, in that particular panel, there is no coarse aggregate, there is no stone chips, that is a mortar. Now, when you embedded the mortar, the bamboo or steel with the mortar, definitely the elongation or the expansion of the steel is much higher, and we want to restrict the thickness of that panel in 3 inch just to minimize the cost. So as professor also told, the low cost is the one of the prime criteria. But in case of the 3 inch kind of the thickness, you cannot use the reinforcement. Reinforcement, if you want to go, you have to go with the ferrocement technology, the 3 inch or less than 3 inch or so. That is one of the issue. Now the thing is, whenever I am going to use the bamboo as a reinforcement material for this BRM of 3 inch thick panel, definitely we have to take in consideration of the thermal expansion also. Yes, this particular building was not 3 years of old. We have not noticed any kind of crack till date because it is already 1 year, and this Kharagpur temperature is widely varying in the summer and the winter. We also have the chicken varnish in the both the side of this BRM that will take care of this thermal stress developed during the daytime or maybe the seasonal change of the temperature. But yes, you are rightly says that we have to see at least 3 to 4 or 5 seasons that how it will going to behave, or we have to do it in some kind of autoclave temperature temperature increment and then reduction and see 2-3 phases or so. So that we have not till now conducted.
Thank you, sir.
Sir, somebody has asked that what is the design life of the bamboo structure which you have constructed or otherwise?
Design life, the panel point of view, it is as good as the other RCC component also. Now we have flexibility in our other component like the 4 bamboo column, the truss systems, and also in the windows and all. So it has its own natural process. People says that if a bamboo is potentially we can do the potential amount of the strengthening by virtue of this smoke treatment or this boric acid treatment or so, it can have a life longer, like 20 plus years or so. But that depends upon 2-3 things. Your area, as professor actually told about the white ant problems or so, then basically the lower portion of the columns and all these things may come under attack maybe within 1 year, or may not be within 1 year, maybe within 5 years or so. That depends upon the how we are going with this treatment, and also day to day some of the maintenance activity. But the best part of is that the exposed bamboo component in our construction is you can add, I mean you can remove and you can add, and that can be because it is all fixed between these 2 caps and those the anchors and the supports also. Professor Chattopadhyay, can you add something?
Yeah, Pankaj, the question was design life. As we mentioned, both of us, that we had used a similar technology for a school building, which has crossed 12 years, and it is functioning. And a school building is put to all kinds of stress by the children. So it has tested the time. It is up and standing there for last 12 years. Our building is working extremely well, and we have had some extreme seasons. So it doesn't show any less longevity than a conventional building. It definitely shows a lot of promise over what bamboo was used, over what bamboo houses used to be. So I think it has a very good prospect of living to the expectation of the users.
Okay, thank you, sir. Any other questions from the participants?
Professor Bhattacharya, I just missed one point which I wanted to confirm. You said there are different species of bamboo, right?
Yes.
Now, which species of bamboo are most suitable specifically for a structural reinforcement, and what criteria governs their selection out of many?
Yes, I cannot tell you the scientific name. So what we can do is that what we did is that we first do the straightness test for that the index for the particular columns also. But for using that as a reinforcement, we did 2 tests, that is the tensile stress and the compressive stress. And we see that what kind of the range of these particular values are come in that particular thing. Range of the values, as I indicated, it is kind of a 80 to 150 megapascal or so. far below the steel, no issue at all. But that particular species, which is coming out to be like straight enough and those kind of the tensile and the compressive property, we used for those kind of
Yeah, and I
structural
can tell you the figures, some of the figures, Praveen. We had
Yes, sir.
tested 5 varieties of locally available bamboo, including Bambusa balba, Bambusa bambus, Bambusa tulda, Bambusa nutans, and uh, the strictus. These were the types that we tried. And as Shankha has just said, that we tried to test their tensile properties, their straightness, and the compressive properties. So here we tried to make a best matrix of all the boxes or more number of boxes getting ticked. So far as the tensile of these properties of these 5 characters are found, I see that the Bambosa Balcoa showed the highest, which is 140 megapixel. Okay, 140, and the lowest or the other ones in the 80s was Bambusa bambus. So we did a very extensive study of the species available. Similarly, I have the figures for the other tests. So this is how we selected our bamboo species. I think we have run over the time limit of 4 p.m. And Pankajji, thank you very much for giving us
Thank
this
you.
chance.
Thank you so much.
Sir, on before closing the session, I would, on behalf of BMTPC and my personal behalf, I am so grateful to Professor Chattopadhyay and Professor Bhattacharya for sparing their valuable time and be available to make their presentation on this bamboo structure, which is a part of a ASHA project, which has been sanctioned to IIT Kharagpur under Pradhan Mantri Awas Yojana, and we are happy that the structure which has been built by IIT Kharagpur is performing very well, and the such a great comprehensive presentation made by Professor Bhattacharya and Professor Chattopadhyay covering every aspect of the bamboo, starting with the species and the basics of the bamboo and how it is to be treated, and the all the how the structure has been constructed, and not in many R&D works that a live structure is also built on the basis of the testing which is done in the lab. It is one of those projects also. With this, I convey my um, uh, gratefulness to both the speakers on behalf of BMTC and myself. And I also convey thankfulness to all the participants. In fact, I was seeing the names in the chat box. I am heartening, and it is very heartening to know that we had participants from all over the country. Out of those around 200 participants, I was seeing some of them have put the places from where they have joined, and from I think across the country we had participants, and participants included students, private sector people, professionals, and we had faculty also from the engineering and architectural colleges also. So it was very heartening that we have a very large spectrum of participants also. And through this platform, I would like to convey that that wallet company which we came to know, Mr. Krishan Mohan Sharma. Similarly, some other companies who are working in this new technology or new material for the construction, I would request them to be in touch with BMTPC, since BMTPC is doing validation and certification of new materials and technologies. And even if they have taken the certification, they can meet us and be in touch with us for any further guidance or promotion or dissemination of their technology or building materials. With this, I am also thankful to our new Executive Director, Shri Arvind Kumarji, who also joined today for this webinar. And with this, I come to the end of this webinar. Although we have taken more time, almost half an hour we have taken time, but it was a very interesting and interactive session, I think, and everybody would have enjoyed this and got a good knowledge on the bamboo technology. With this, I thank all of you for joining this webinar. Thank you very much. And many people have, many participants have requested for the presentation also, sir. We would request the speakers to share the presentation if possible, and we can send you the copy of the presentation to all the participants who have joined today. Otherwise, I think Mr. Dilip Kumar can confirm. I think we have recorded this presentation. I think it will be available on our YouTube channel also, BMTPC.
Yeah,
Mr.
Yes, it will be available tomorrow morning. Yes.
Tomorrow morning, this recording with full presentation will be available on BMTPC's YouTube channel also. And if we are able to get the presentation from the speakers, we will email all the participants the presentation also. So with this closing remark, I thank once again to all the participants. Thank you very much.
Thank you. Thank you very much.
Thank you, sir.
Thank you.